Good morning, beloved students. Welcome back to our FB Live in Science 8. Let us now recall first the discussion that you've done together with Sir J.C. de Guzman. He talked about work and energy, especially or specifically kinetic and potential energy. And for this morning, we will be dealing with sound, light, and heat. And we will be focusing on the effect of temperature on the speed of sound. Before that, we will have first our objectives. We should be able to first determine the effect of temperature on the speed of sound. Second, we should be able to compute the speed of sound in air at different temperature. And before that, you need to guess first the jumbled letters on the following slide. Are you ready? Within 10 seconds, class, I want you to guess the jumbled letters. Okay? So let's start. Can you guess now this? Two, 1, 0. What should be the answer? Type now on the comment section. Exactly. This is speed of sound. You're good. Next one. Four, 3, 2, and 1. The correct answer would be Hertz. Correct. Now, let us proceed to the third slide. How about this? I know it is very easy for you to guess. Type now your answer on the comment section. Okay, the correct answer would be none other than frequency. And how about these words? And it is very easy for you. Time's up. The correct answer is meter per second. And next. Okay, time's up. What should be the correct answer, class? It should be exactly correct. That is velocity. Okay. Now, those terminologies are quite important in our discussion. And we will discuss those first: velocity, meter per second, and those familiar words. So let's have first the terminologies, units, and its symbols. First word is temperature. Temperature has its units and symbols, which is degree Celsius, degree Fahrenheit, and then Kelvin. Okay? How about second terminology? The second terminology is the speed of sound, which symbolizes as small letter V. And its units and symbol would be meter per second. And the third terminology is velocity, which the unit symbol is meter per second. And the fourth one is none other than frequency. So frequency has its own symbol, which is small f. And the unit for frequency is hertz, or in symbol, it is capital H, small letter Z. And for the last terminology, that is wavelength. Wavelength has its own symbol, which is inverted Y. Inverted Y, also known as the lambda. And the unit for wavelength is meter. Now, before we proceed to our discussion, I want you to differentiate the word speed and velocity. Sir, why both these words has same unit and symbols, which is meter per second and also meter per second for velocity? What is the difference between velocity and speed? Anyone? Correct. Actually, speed has something to do with how fast something moves, while velocity is the speed with direction. Actually, Sir JC talked about that last meeting. Okay? Any questions so far? None. Okay, let us move on to our next slide. I have a trivia for you. Did you know that sound waves do not travel through vacuum? Exactly. Sound waves do not travel through vacuum. Sir, what is the reason behind that? The reason behind that, it is because sound waves are this example of mechanical wave. A mechanical wave, also known as defined as the vibration of energy that cannot transmit from one place to another. So sound waves here, class, do not transmit energy because there are no particles or matter that the sound waves can travel. Okay? So do not forget this trivia for you. For the last time, sound waves do not travel through vacuum. Okay? For the next slide, let us define the speed of sound. The speed of the sound may differ for different types of solids, liquids, and gases. So these three different types are also known the three states of matter. I know you are very familiar with the states of matter, okay, which are the solid, liquid, and gas. Actually, there are lots of states of matter. We have plasma or Bose-Einstein condensates. Just additional information for you. And also, the speed of the sound does not depend on the source but on the medium through which they move. Please do take notes those words that I highlighted here. We have the speed of sound, the word not, source, and then medium. Because the speed of sound, as the word says, is not depend on the source but on the medium through which they move. Sir, what do you mean by medium? Medium, these are the matters or the objects, things that the sound waves or the speed of sound can travel. Do not forget that. Now, aside from that, there are several factors affect the speed of sound. And what are those? One of the several factors that affects the speed of sound as it travels through a medium is humidity and air pressure. Do not forget those several factors. We have the humidity and also we have the air pressure. Now, one of the conditions, okay, that affects the speed of sound is the word temperature. The word temperature has something to do with the degree of hotness and coldness of a specific object. And we can define now here that temperature is one of the conditions that affects the speed of sound by changing the density of the medium in which a sound wave travels. Do not forget this. So one of the conditions that affects the speed of sound is temperature. Okay? Any questions so far? I hope you are taking down notes about this lesson. Now, we will proceed to a sound wave. When we say a sound wave has a speed that is mathematically related to the frequency and the wavelength of the wave. Do not forget these words. Sound wave has a speed that is mathematically related to the frequency and the wavelength of the wave. And for you to understand about frequency and wavelength, let us discuss first the meaning of frequency. So the meaning of frequency here in physics It is the number of waves that pass a fixed point in unit time. So I highlighted the words number of waves. So do not forget that for frequency, those words which is number of waves. Okay? Sir, how about wavelength? Wavelength is the distance from one crest to another or from one trough to another of a wave, which may be an electromagnetic wave, a sound wave, or any other wave. So in order for us to understand, I highlighted also the words distance from one crest to another crest. Did you get now, class? The difference between frequency and wavelength? You're quite confusing? So if you're quite confusing, I prepared here the parts of a wave. So the parts of a wave, as you notice on the picture shown on the screen, we have several parts. We have the origin, which is on the midline. We have the wavelength from top and then the bottom wavelength, which is the distance from one crest to another or from trough to trough. And we also have the what we so called the amplitude, okay, which is the height of the wave. Okay, so that is about the wavelength from one crest to another, and then from trough to trough. That is what we so called the wavelength. It is the distance which measures in meter. How about frequency? Frequency has the low, has the medium, and has also the high frequency. So these three terms, do not forget, it is quite different from each other. Just take a look at the wave. First, take a look at the low frequency. What have you noticed on the wave? Exactly. Waves are too far from each other, while the medium has the slightly too far. While the high frequency, it is too near the wavelengths. So this is the high frequency. And then we also have the time and amplitude. Okay? Now, can you differentiate now the difference between the two? Okay. Let us move on now to our next slide. And according to this next slide, mathematical relationship between speed, small v, frequency, small f, and wavelength has this equation. We have the speed is equal to frequency multiplied by wavelength. Do not forget this, class. This has something to do with the mathematical relationship between these three words, because these are very important in our discussion. As we go along, later, we will compute the speed, the frequency, and also the wavelength. Okay? Now, in order for you to understand more, I have here the letters. Okay? So, V, small v is for frequency, for speed, is equal to frequency, small f, multiplied by lambda, which is wavelength. Okay? Understood, class? Okay, let us move on now to the next slide. And it is all about, again, those three words. We have the speed, we have the frequency, and we have the wavelength. So, class, I want you to take down notes of those words and symbols because these are very important in order for us to compute something. Okay? So, I prepared here a triangle. Okay? So, let us discuss first, if speed is missing, sir, what should be the formula? If the speed is missing, the formula would be small b is equal to frequency multiplied by lambda. Sir, how about if the lambda or the wavelength is missing? What should be the formula? The formula would be, if the lambda is missing, the formula would be lambda or wavelength is equal to speed divided by frequency. Sir, how about if the frequency is missing? What should be the formula? The formula is frequency is equal to speed divided by lambda. Okay, so I know you are hard to explain or hard to compute because there are so much computation in physics. But I prepared here a table which can give you or which can help you to understand about the usage of formula. So, if you want to find the speed, class, look at this. If you want to find the speed, which is small v, what should be your formula? You need to use the v or speed is equal to frequency multiplied by wavelength. Sir, how about frequency? If you want to find the frequency, okay, you need to use this formula. Frequency is equal to speed divided by lambda. And for the last, if you want to find the wavelength, you need to use the formula lambda is equal to speed over frequency. Can you now understand, class? I hope I gave you the easiest way in order for you to solve the missing. Okay? Next, aside from that, we need to know also the average of the speed of sound. And the average speed of sound through air is about 344 meters per second at room temperature. Class, this speed of sound or the average speed of sound is fixed or constant. Okay? At room temperature. So meaning, it always gave the value of 344 meters per second because that is the average speed of sound. Do not forget those meters per second, which is 344. Okay? Aside from that, for every degree rise in temperature, the increase in the speed of sound is 0.6 meter per second. Do not forget this. It is for every degree increase or rise in temperature, you need to also add the speed of sound, which is 0.6 meters per second. Okay? Aside from that, at 0 degree Celsius, the speed of sound in the air is 344 meters per second, as we said a while ago. Now, how about if it is in 1 degree Celsius? At 1 degree Celsius, class, the speed will become 344.6 meters per second. Sir, how could it be? Okay, it is determined of this value. Speed is equal to 344 meters per second added to 0.6 meter per second over degree Celsius multiplied to temperature. This is determined by the use of this equation or formula. So do not forget to take down notes of this formula, class, because you will use this in our computation. Now, if this is the value, let us define what is B. B here, small b, is the speed of sound, while the capital T is the temperature of the air. Because the symbol for temperature is capital T, while for small t, that is, what should be the answer? Exactly, that is time. So, how about this one? At a temperature of 1 degree Celsius, we said a while ago that the value of the average speed of sound is 344. But how about if it is already 1 degree Celsius? The answer would be 344.6 meters per second. Now, let me explain again. So, we need to substitute first we need to get the equation. Second, we need to substitute the temperature into 1 degree Celsius. 344 meters per second added to 0.6 meter per second over degree Celsius multiplied by 1 degree Celsius. Now, have you seen the same unit on our formula or equation? Exactly. That is meter per second and degree Celsius. But in mathematics, we need to cancel this same unit, okay, which is degree Celsius. Okay? Now, what should be our answer? Our answer should be speed is equal to 344.6 meters per second. Okay? That would be the answer. Now, for every solution class or for every problem, okay, you need to put the statement. For example, what is the speed of sound of a temperature at 1 degree Celsius? Okay? You need to put the statement. Here, we already done getting this statement, which is the speed of sound at 1 degree Celsius. Okay? And then you need to also box the final answer. Okay? Now, it's already computation time. I know you are ready and excited in our computation time. But before that class, I want you to use the GAPS method. Sir, what do you mean by GAPS method? GAPS method is very important in problem solving. G stands for given, U stands for unknown, F stands for formula, and letter S stands for solution. Now, I added here a statement, then box the final answer. Sir, why did you add that? Because it is good to answer if your answers are all complete, and then box the final answer. So do not forget the use of GAPS method. Given, unknown, formula, solution, and also the statement, and then box the final answer. So I know you are ready in our computation. Let us move on now in our computation. Okay, first problem. Okay? Sample problem number 1. In sample problem number 1, what is the speed of sound in air at a temperature of 25 degrees Celsius? So class, I want you to analyze first our sample problem number 1. Again, sample problem number 1, what is the speed of sound in air at a temperature of 25 degrees Celsius? So first, you need to use the GAPS method. Do you still remember the GAPS method? GAPS method, G stands for given. Exactly. Now, what is our given on the problem? Our given on the problem is temperature, which is equal to 25 degrees Celsius. That is our given. Sir, is that all? What do you think is the answer, class? Okay, there's something is missing. Actually, there is the hidden given. And what is that, class? Anyone from the class? Exactly. Okay? The hidden given is speed of sound. And that is, what should be the answer? For this one, given, for the speed of sound, it should be 340. Anyone? 344 meters per second. Class, we talked a while ago that this given speed of sound is constant. constant or fixed. Meaning to say, it is not changing. Okay, so we're done now with given. What is next? That is unknown. U. We have the G given. U unknown. So what is missing in this computation class? The missing in this computation, because we are asked to know the speed of sound. So that is small b. Okay? Do not forget that. Now, how about the next one? What do you mean or what is our formula? F, formula. Our formula is speed of sound is equal to 344 meters per second added to 0.6 meter per second over degree Celsius multiplied by temperature. So that is our formula. Now, let us move on now to solution. For solution, you need to get the formula, which is B, speed is equal to 344 meters per second added to 0.6 meters per second over degree Celsius multiplied by what should be the value of our temperature in the problem. This one. What should be the problem? What should be the value of this one? We need to substitute this into 25 degree Celsius. So 25 degree 25 should be 25 degrees Celsius. Okay? So degree Celsius. Now we need to cancel this same unit because we are looking for the speed of sound. Okay? At a temperature of 25 degrees Celsius. Now, we need to multiply first or use the what we so-called GEMDAS or PEMDAS. So, GEMDAS stands for group, exponent, multiplication, division, and subtraction. Okay? So, 344 meters per second added to 0.6 multiplied by 25. What should be the answer? So, let us compute. 0.6 multiplied by 25, the answer would be 15. Okay, 15 meters per second. We don't need to cancel out the unit class because we are looking for the speed. So, our unit here is constant. So, speed of sound is equal to 344 meters per second added to 15 meters per second. What should be the answer, class? Okay. The answer would be 359 meters per second. Okay. Let us go back now to our question. What is the speed of sound in air at a temperature of 25 degrees Celsius? Okay? So, here, we need to put the statement. So, the statement is this. Speed of sound is equal to 359 meters per second is the speed of sound in air. And then, you need to box the final answer. Okay? As easy as this. So, do not forget, class, this computation. Okay? I know you are good in computation, and let us proceed to our second computation. Are you ready now for the second computation? Kindly ready your scientific calculator or calculator in order for you to participate in our discussion. Okay? So next, our sample problem number 2. Sample problem number 2. A female vocalist with an alto voice can sing as low as 80 hertz. Given that the speed of sound is 265 meters per second, what is the wavelength of the sound waves? I repeat, a female vocalist with an alto voice can sing as low as 80 hertz. Given that the speed of sound is 265 meters per second, what is the wavelength of the sound waves? So here, we need to use again the gaps method. We need to use the given. Okay? So for the given, we have here, actually, that is frequency. Frequency is equal to 80 hertz. Okay? Next, another given class. Take a look at our given. So the given is the speed of sound, which is 265 meters per second. Okay? How about the unknown? Are we done? By the way, are we done with given? Do you see any other given in our problem? Okay, none. Okay, let us proceed now to our unknown. So, in the given, what are we looking for? Anyone? Exactly. We are looking for the lambda or the wavelength. Do not forget the inverted y. Okay? That is lambda. Okay. How about, sir, the formula that we are going to use? The formula, we are done with given and unknown. How about the formula? So, this remember the triangle a while ago? So, that is speed on the top, and at the bottom would be frequency and then lambda. And since we are looking for this one, lambda, what should be our formula? Okay? We need to cover this one. What should be our formula? Okay, correct. Our formula would be wavelength is equal to speed over or divided by frequency. So, this is our formula. Okay? Now, let us move on to our solution. By the way, class, is this given, unknown, and formula are already clear to you? Okay. I hope it is already clear as like a sun. Okay. By the way, let us move on to our solution. Okay. In our solution, you need to get first the formula for your reference. Okay? So, our formula is wavelength or lambda is equal to speed over frequency. Okay? Now, after that, you need to substitute. Okay? Lambda is equal to 80 hertz over 265 meters per second. Okay. Now, class, when we say substitution, it means you need to change the variables or the letters into numbers. Like, in the given. Okay? For example, this one. Okay? I think I'm not correct with regards to this formula, substitution. Actually, class, this is, sorry. Okay? Actually, class, this is 265 meters per second. Sorry for that. Okay? And this one, frequency should be 80 hertz. But we are looking for this lambda. And the unit is meter. Am I right? This lambda, or the inverted Y, or the wavelength, okay, has its own unit, which is meter. Now, there is only 1 meter here. How are we going, or what are we going to do in order to cancel same unit? Actually, class, hertz is equivalent to 1/second. So do not forget this. So hertz, that is Z, hertz is equivalent to 1/second. By the way, class, the word hertz came from the German physicist, none other than Heinrich Rudolf Hertz. Okay? Actually, hertz is one of the proved conclusively the existence of electromagnetic wave. Okay? So do not forget that. Hertz conclusively proved the electromagnetic waves. Now, moving forward, we need to substitute hertz here in the given into second. Is that clear to you, class? Because hertz is equivalent or equal to 1/second. Now, let us go back to our solution. Since there is already the same unit, what shall we do? Okay, you need to cancel. Cancel same unit. And the remaining unit is meter. Okay? So, wavelength is equal to 265 meters over 80. So, what should be the answer? Can anyone answer my question? 265 meter over 80. What should be the answer? It should be 3.31. Okay. It should be 3.31. Okay? 3.31, that is the value of wavelength. Now, moving forward, the statement is 331 meters is the wavelength of the sound waves. And then, sound waves. So, and then, box now the final answer. Now, some of you are questioning us, teachers. Sir, ma'am, how can we check our answer if it is wrong or not? Okay. Let us check. For example, 3.31 meter is already given. And the missing is the hertz, for example. Hertz, which is this one. Missing is hertz. Do not forget that our given in the problem is 80 hertz. So, let us change. So, we have the lambda, which is 3.31 meters. And our unknown here, class, our unknown here, let me erase first. So, do not forget, our reference, class, is, our reference here is frequency. We need to get the frequency, which is 80 hertz. Do not forget this. We are checking our answer if it is correct or not. Now, moving forward, okay, so our solution, our unknown here is frequency. Okay? Our unknown here is frequency. And our formula for frequency, that is speed over lambda. Am I correct? So let's check. If this is your triangle, V, okay, over F and then lambda. Okay, so we are correct. Now, moving forward, what is our solution? Let us get first the frequency. Okay, frequency is equal to V over lambda. Then, you need to substitute. The value of B is 265 meters per second over 3.31 meter. Okay? So, since we are looking for frequency, our unit should be seconds. So, we need to cancel same unit, which is meter. So, next, frequency. So, we need to divide 265 divided by 3.31. The answer would be 80.0 seconds. So, that would be the answer. Or 80 hertz. Okay. Any questions so far, class? I hope you learned a lot for this computation. So let us go back now to our discussion. Okay. Now, I know you already done solving those problems, and I hope you learned a lot from those things. And I have here, I prepared here, questions for you. Okay? Question and answer portion. For the first question, sir, what can you say about the speed of sound if the temperature increases and decreases? Anyone? What can you say about the speed of sound if the temperature increases or decreases? If the temperature increases, the speed of sound would be moving faster. Okay, so that is directly proportional. As the temperature increases, also the speed of sound increases. And then how about if it decreases? Same. If the speed of sound decreases, also the temperature also decreases, or vice versa. Okay? So I hope you get the answer for this question. Okay, how about this last question? Last question, does sound travel faster or slower as temperature increases? Actually, I already done answering that a while ago on question number 1 and also in our discussion. Now, the answer would be, again, as the temperature increases, the speed of sound travels fast, also increases. And vice versa. If the temperature decreases, the speed of sound would also be decreases. That is the reason why some of the concert in our country on other countries are on the evening. Okay? Not on daytime. Because the speed of sound on evening is slower. So you can feel better the music. Okay? So that will be all for today. I know you learned a lot from this session, which is the effect of temperature on the speed of sound. So that will be all for today, class. Goodbye. Thank you. And God bless. Do not forget also to like, share, and subscribe my channel. Click the subscription button and my pranks. So if you want to laugh, just watch my pranks. And also, hindi lamang yan, ginawa ko po itong video, it is because for this reason. Next one is study and meditate the genuine gospel. So let us spread the gospel of Christ in this mid of crisis. So do not forget again to subscribe my channel Poly TV or Teacher Poly TV.